Imagine, if you will, a dark, gloomy sky, clouds up on the horizon, rain pouring down, seemingly forever. I know it's kind of difficult today, but anyway, imagine it. And then a magical thing happens. The rain stops. The sun slips in through a gap in the clouds, and you see the most beautiful sight up in the sky, a rainbow. I cannot bring within these halls the cloudy sky, the rain, the sun shining its rays through over 100,000 kilometers down on our little Earth. But I can bring this little prism. And if I hold it up here, like that, you can see the same thing up on your wall. It is a spectre of light, a rainbow. Now, the light that comes out of this projector is white. It is a synthesis of electromagnetic waves of different frequencies. The higher frequencies being blue, the lower frequencies being red, and the in-between frequencies being all the in-between colors. Now, once this light comes into this crystal thingy, an interesting thing happens. Actually, two interesting things, but let's start from the first one. Light moves slower inside the crystal than it does in the air. But light still likes to travel to places fast. It wants to take the least time to go to anywhere it goes. So, we have a light beam coming from here, point A, and it wants to get to a point B right in there. It won't go in a straight line, because you have to traverse this whole distance inside there where it will move really slowly, and that would take too long. So what it does in real life is a light beam that goes further up here, then turns at an angle to reach that point B inside the crystal. So it will take the least possible time to go through this distance. So at the border between the crystal and the air, we have an angle where the light turns, and that is what we call refraction. Now, the second interesting thing that I said is that the speed of light isn't the same for all frequencies in this crystal. It's different, the speed for blue, different for red, etc. That means that there's a different refraction angle for different frequencies. And that is why, by holding this crystal like this, the beam of light comes over here, you see the different frequencies shifted to a slightly different angle in forming that spectrum on the wall. Now, when we go to a rainbow, things are slightly different. We don't have a single prism. We have water droplets, which are round like this, you see. And when we have light coming from here, you have a refraction when they first come in, reflection when they hit the other side, and a second refraction when they come out. So they form an angle of about 42 degrees. So, if we want to see the light coming from those droplets, we only see those that are in a circle of 42 degrees from our line of sight. And that is the bow that forms in front of our faces.